Oh, yes. No answer to the time I didn't remember the other either. If they were really close. They can't probably do that. I don't think so. Trying to think I can look at it. I think I know what I'm doing. No, that doesn't even. Oh, how did it start? Oh, that's possible. I'm trying to avoid that. That doesn't mean that I shouldn't do it. I did look online. But you can't plug it in the box stuff online. That's one issue. Nothing much. Nothing interesting time. Been there for hours. Got the dishes going. That looks creepy. Looks like you went to shark it. That's all I do. Yeah.
Weird northeast.
Yeah.
We're still really cold.
Next Wednesday is going to be just a ridiculous seminar day.
Huh? Yeah, no, it's this,
We've got
one I just finished, and now another one coming.
Well, on Wednesday, we have a faculty candidate at 9:45. Then Look, there's another.
Yeah, there's another one.
Yeah.
And Alex is coming at 1, and then there's another seminar at 2:30.
Yeah, Matthias Rock is part of it.
Got the quarterback?
No,
Oh,
no, substantially smaller than that.
You don't see that name. Sucks.
Interesting storm. I don't really know what's going on with it, but the reason I'm talking about it is because it's gonna be 50-foot swell on the coast of Portugal.
Really?
Yeah. There's a famous surf place, Nazaré, Portugal. It's gonna be wild. That's it from me. I guess I got everything. I didn't want to go away with.
I wasn't looking up there.
Yeah, it's kind of a weird storm. I don't know exactly how it even works. Because I didn't get any time to look at it in detail. I can't wait till we get it goes 19, we can look at the Central Atlantic, I hope. We need an Atlantic one.
Well, there is, I mean, GOES 16 is the east one, and GOES 17 will be the Pacific. I'm not sure there are plans to have another GOES. I mean, maybe there's a UMetSat that's going up or something, but I'm not sure.
These parts are screwed up again.
What's that?
These parts are screwed up again.
Your plots are screwed up?
The first one for the 60 is says Saturday last week. What's that all?
Oh, that's Monday. Today, I can throw in the observations.
Somebody steal your,
Yeah, it seems to be migrating from one room to the other.
I'll go ahead.
823.
I wouldn't want to either. So we could try it on Friday instead of on Monday. Not terrible.
Just good enough.
I can see your goals.
Nope, not above my head. I'm wishing for the days rain. Maybe I'll come back to this one. But Croy just wrote to me, golf season is nearly upon us. I got to thinking about that.
Yeah?
He got a new puddle last year and took him off summer to learn how to use it, but he's very good. There are all the little swirls on the backside. You see that? Even in this image.
Water vapor is pretty cool too.
I think we're gonna get started. Okay, let's get started. Thanks for coming to our weather discussion. I'm gonna turn some lights off so it's a little easier to see. We've had a wild start to March. So Pete gives us this weekly satellite.
this is infrared satellite image beginning about a week ago and ending today. So you can see we've had a collection of storms along the East Coast. I think that the one of them is on this one, and that's the big storm from earlier in the week.
That was kind of last weekend.
Oh, this was last weekend, and then there's another one coming.
There's another nice one out over the Atlantic in between too that formed.
It's been a very energetic Atlantic period and continue to be relatively pouring in the Pacific. So again, having GOES 16 as opposed to 17 is great right now. So two big events on the East Coast. The first one last weekend was a big wind event in much of the metropolis or megalopolis down the coast. Very heavy winds, heavy rains, and the sea came up in places in southeastern Massachusetts like it hasn't in quite some time. So Situate, Barnstable had a gust. I think it was last week, Brian, we had just heard about the gust at Dulles at 70, and then later on in the afternoon, Barnstable, Cape Cod had a gust at 93. And that was 1 or 2 miles away from Jennifer Francis's house. So she was corresponding with me the whole weekend about how wild it was. They had several trees go down on their property. None of them hit the house, luckily, but it was absolutely wild, she said. It was like a hurricane. So they had a really intense event last weekend. And then was it Monday and Tuesday, or Tuesday and Wednesday, they had the big snow event in the I-94-5 corridor, but it was mostly to the west of that. I think Scranton, Philly had a mix of rain and snow, and places just maybe a little bit to the west of Philadelphia had really heavy snow. Same was true in Boston. They started in rain and then ended up with some snow at the end, but not that much. Central Massachusetts was a different story. It was pretty heavy snow in the central part of the state, and then in much of downstate Vermont and downstate New Hampshire, especially in the western part of New Hampshire. So it was a wild weekend. I mean, a wild week, period of 5 days. And it appears as though there's yet another threat looming. And this particular storm, we got a call, Michael and I, Michael got the call, and I happened to be next to him talking to him, and when Greg Postel from the Weather Channel called early last week, and we were just talking about the Tuesday event, and I said, forget about this Tuesday, look toward next Tuesday, because it looks like it's going to be a really big event. And he, of course, laughed at me, which was the right move, as it turns out, because Michael will say more about this. The forecast for the coming event, now maybe the biggest threat being the Middle Atlantic as opposed to New England, has really been a forecast problem, right? And every single day and sometimes every single run has changed the nature of the forecast for that event. So it's been a very difficult predictability issue. And I think this is in the context of a region that's been rather beleaguered by some pretty intense late winter storms. You don't want anybody here to be caught off guard. But on the other hand, every single day, sometimes, as I said, multiple times in a day, the forecast is changing.
Right.
And so it's difficult.
Yeah, an interesting aspect of the last snowstorm was it was a storm, I guess, was
It
that
definitely was.
in New York City, they were, forecasting maybe double-digit total, so exceeding, 10 inches or a foot, and it was about 2.5 inches of snow.
Yeah.
But it really was, I mean, was it a bust or not? I mean, if you went 30 to 40 miles just to the northwest of the city, there were accumulations there that were 2 feet.
Right.
And
Right.
so it was really a forecast challenge that remains is quantitative precipitation, but also with winter storms and the sort of banded nature of how the precipitation band's set up. It's, I think, an open question whether or not in our lifetimes we're going to be able to see a solid prediction of snowfall 24 hours in advance when you have these bands.
Yeah, I agree.
Does the predictability exist for that is an interesting question.
It's a very interesting question. And whether or not we are inadvertently scaling people's expectations upwards when we are going to reach that barrier, I think, is really interesting.
Yeah, we scaled the expectations upward, but we scale the model resolution downward to get the
that's right. That's
higher
right.
resolution, but will it buy anything?
It's a tricky thing to know what's going to come of that. So one of the other things that I think would characterize both of those storms on the East Coast is that they did not follow traditional nor'easter trajectories, which is usually an upper trough digs and northwesterly flow over the eastern, maybe the central part of the country, like you're seeing here, and then develops a cyclone over Florida or off the Carolinas, and then goes up the coast. Both of those events came right across us, and in fact, the first one, the Friday last week, when we expected on Wednesday of last week, 0 to 12 inches of snow was a reasonable forecast because it was either going to be all or nothing. It turns out it was nothing for us. Skipped just to our south, developed to our south, and moved quickly to the east, and that became storm number 1. And then a similar trajectory was storm number 2. So it's been an unusual set of circumstances that underlies the development of these storms. And I can't tell you that I have any particular insight on them without having had the time to spend looking at them in any more detail, except to note that it's been an unusual path, more Clipper-like than nor'easter-like. But the effects are if you're living in Situate and your living room is flooded, you don't particularly care if the storm came from Iowa or if it came from southern Georgia. You don't really care about that. And I think that's a fair thing for those people to say.
Yeah, it's more than just a difference in accent.
Yeah, that's right.
The other interesting aspect of this is, Pete's loops nicely show is that the sort of complexion of the general flow over the Western Atlantic and Central North America has changed over the last couple of weeks. Remember we had that broad subtropical ridge that extended almost into the central part of the United States and provided us, significant warmth and also that heavy precipitation period a few weeks ago. Now it's been displaced with generally a large-scale cyclonic circulation and westerly flow over much of the Western Atlantic.
Yeah, that's right. That's definitely true. So what we'll do today is, in the forecast part, take a look at the development threat for the weekend on the Middle Atlantic states. And in the initial part of the forecast conversation, we'll talk a little bit about current conditions across the country, large-scale setup. And then I want to bring you over to Europe for the weekend for just one little snippet about a storm that I don't know much about how it's developed. It seems to be an intriguing development. It may be a result of debris from prior storms in the Western Atlantic, but it has going to have a really big impact on the coast of Iberia, especially Portugal, which is most of the west-facing coast. And they have a propensity for really big waves, and I want to show you a wave forecast for that part of the world later on in the discussion. But from here, let's go to our current satellite, so that we know we're only looking at one short period of time here. So here's the visible satellite imagery for the last 6 or 7 hours. And so you can see there's really much of the synoptic scale development activity is off the coast of continental North America. And a lot of not so well developed and not so well organized cloud features are lingering over the continent. So there's a stream, we'll see this in the West Coast satellite images, a stream of clouds, not only high clouds, the visible indicates they're deeper than just high clouds, but substantial fraction of that's high cloud and presumably water vapor content heading straight from the central Pacific subtropics toward the coast of California. I have not had the time to investigate whether or not this indicates a fairly substantial threat for heavy rain in the valley area of California and the coast, but we can do that. And then over the north central plains, some high clouds. I think also we'll see in the infrared, it looks particularly obvious that it's connected somehow to this flow from the southwest. But there's also, of course, that invasion of disturbances from high latitude. Particularly interesting at this time of year is the population of tropopause polar vortices. They either get destroyed by the sun rising or they get excavated by the large-scale flow and they enter the mid-latitude flow and make it wavy. And it seems to be one or the other. That's very preliminary, it seems to be. There are years where the flow is not very wavy in March and the sea level pressures are not very low, and they seem to be consistent with years in which you don't have substantial evacuation of these tropopause polar vortices from the high latitudes to the mid latitudes. Steve Cavallo and I are looking at that problem in a little more detail.
It looks like right now the polar night jet is completely gone.
Okay. We'll see that.
That's the one that's up high in the stratosphere.
Yeah.
But I think it's gone.
Yeah, okay. And that would be early. It's supposed to be more like this time in April. So it would be an early decay. Yeah. That'd be a fairly early decay. It may just be the case though. Let's take a look at the water, not water vapor, the infrared, just to see if there's some sort of connection in the higher clouds. Probably, that's hard to say that there's any particular connection. So I'll take that now. I thought that I saw that earlier today. But this is really deep cloud and radiating at very cold temperatures on the top of it, just like tropical clouds here. So at the latitude of Los Angeles, Huntington Beach, same as the stuff that's going on the west coast of northern part of South America. Okay, Pete, could we look at the West Coast satellite image? And the first time in a while, actually, it seems to me, we have, well, first of all, we've seen quite a number of these features from the tropical central Pacific. And here's a new one, seemingly making its way towards San Francisco. So that's going to be interesting in the forecast. This is one of the nicest looking cyclones we've seen in the Eastern Pacific all winter long. It's been kind of a boring winter in that regard. So this one has a fairly intense circulation right there on the Kenai Peninsula centered there. Cold air aloft, indicated by the extent and the temperature at the top of these clouds, the depth of these clouds, are deeper than the ones that straddle it, or surround it, I should say. And some of these actually develop their own little circulations, perhaps in the lee of the Aleutians. This one right here catches my eye. See how that feature comes around? It may just be an optical illusion that there's no circulation there. It's impossible to know if there is a circulation, but it does look to me like that thing starts to rotate a little bit cyclonically. And don't see anything else in this particularly large cluster of deep convective clouds. And then there's a continuous stream of cold air coming across the eastern Bering Sea, just off the coast of Alaska. For certain people are in lawn chairs seeing Russia just across the strait. So, let's take a look at the upper level charts now, if we could, Pete. Wait a minute. Surface radar. Surface radar first. Surface radar. So the radar is not so interesting today as it has been much of the week, but that's not saying much. The week was really exciting. But a lot of lake effect snow in the lee of Lake Ontario and Lake Erie, across Ohio, Pennsylvania, parts of New York State. I'm not sure this is all lake effect. This seems to be quite extensive, and it looks like it has its own little convective elements coming across well after the flow has come off the lake. I don't know if that's routinely the case or not. So this looks a little bit more interesting than the normal lake effect, which is kind of linear bands that stream off the lake, more or less, like this one here is maybe one such band. And then there's a band of precipitation. I'm not sure yet, haven't looked at the surface objects, whether or not it's all precipitating down to the ground. There's a chance it's too dry, like we had the other day, where the precipitation was coming in on Wednesday before, or Tuesday before it really started to hit. But here you have a band across Iowa and parts of Illinois and Minnesota. And then here's some of the precipitation that seemed connected with the southwesterly flow out of the subtropics, but this might be a separate piece here along the Idaho-Montana border. It's linear, it's got an interesting structure to it. I don't know what it's connected to in a synoptic sense. Something interesting about the topography here in Wyoming. And then if we can slide a little bit, maybe we'll see a little bit more if we can slide further to the west. I don't know how far offshore it goes, no, not very much at all. So here's the northern extent of the precipitation that does, I think, have a foot in the central Pacific subtropics. And that's in the northern part of California. More to come there, it looks like. Okay, let's take a look at the surface map.
Real quick, Austin Thomas is joining us online today, and he says the snow is struggling to reach them in Burlington, Vermont, if the sun is out for most of the day.
Oh, so up here they're seeing mostly sunny skies with a few convective snow showers to the west, and they're not quite getting it.
Yep. Thanks, Austin.
Let's take a look at the surface map. And we'll zoom in first in New England. And I guess you can see some light snow in Albany. Not a lot of stations reporting in the northern, the eastern part of upstate, but I'm sure there's some light snow. There's some here near Buffalo. I guess not Buffalo. I forget is that Syracuse?
Watertown.
Oh, Watertown. Okay. And then Ithaca's up in here, and there's no report yet from them. So there's light snow widely across the northern part of New York State. Light snow also in western PA and in northeastern Ohio. All of these places, of course, benefiting from lake effect. Some lake effect rain further to the east in Pennsylvania. And even some lake effect immediately off the lee of Lake Michigan in the state of Michigan in both northern and southern locations. And we are pretty dry. And I think the same is it's not so true over Iowa. So we got a couple of spots where it is actually snowing lightly. One's in Des Moines, one's up to the northwest. Light snow with dew point depression to the northwest of only 4 degrees. So the column's fairly moist. 10 degrees down near Des Moines. So it did take a while, perhaps, for that precipitation to make its way.
You know, I don't know how those could be lake effect storms because the temperatures aren't much warmer than the lake.
Which ones? Over here?
Are much colder than the lake. The land temperatures are in the low 30s. The lake's got to be in the low 30s now too.
Yeah, it's a good point.
You need about a 13-degree contrast to get a good lake effect. It's just not enough.
Yeah, the cyclone, the circulation is offshore. There's not really a cyclone anywhere over the eastern part of the lakes. It's kind of interesting.
I don't think those
There is a bit of a
Yeah,
trough.
that's interesting.
They're just showers.
And they didn't look like it.
What we noticed yesterday in looking at the weather, there was a series of small vortices coming across. They're coming out of Canada and we watch them going across Huron.
Hmm.
And I think there's some kind of an upper level, very short-wave disturbances are moving across it, creating showers.
Very interesting.
It certainly looks like lake effect on that picture. Yeah, that.
There's only one image.
No, I mean, that looks like a lake effect.
So all of this is where I had this.
That's from March 7th. That's old.
Oh.
Something's
Oh, that's cool. Okay.
Yeah, so that's an open question, a very interesting one. It certainly didn't look like typical lake effect bands or lake effect elements on the satellite, on the radar. So that's curious. All right, let's go further west. I think we saw a little bit of precipitation on the border here, and it is actually falling to the ground. Is that Great Falls, that moderate snow, or Idaho Falls? And then light rain further in the south and east. And then no reports of precipitation in Northern California, though. You're 56 or 52 because you're on the coast. Dew point depressions are fairly large, 6 or more degrees. Perhaps it's just not falling to the ground yet in those locations, and may later on. And then it's warm in a lot of places. We got temperatures in the 70s across much of the border of Oklahoma, Texas, and then high 60s and 70s across the whole state. And it's also fairly warm in South Florida, but not so warm in North Florida. It's only 59, 60 degrees. This is midday for them. But this is not a particularly warm day for a place like Jacksonville, 61. I mean, none of us would argue, but 61 on March 9th in Jacksonville, I don't think you'd get very excited about that. 70
in Key West.
Yeah, 65 in Key West with a northeast wind, dry, but cool.
Yeah, nice front over through Oklahoma and central Texas, or northwestern Texas.
So we'll slide back there to northwestern Texas.
Yeah, so west of Oklahoma City, see the wind shift.
All right, so here's your southerly winds. There's a couple of weird odds there. That one's a little bit weird, but it's right on the front maybe. These are all southwesterlies, and then suddenly your northerlies come in over the panhandle. Look at the dew point depression. 59-degree dew point depression. That's Hall of Fame for today. 70 winds, 70-degree dew point depression. Amazing. So going right up to 65. So 70 is the winner for the day that I've seen so far. So that's pretty good. Dew point depression. So let's see. And there's a wind shift associated with that line of dew point depression, isn't there? So that's kind of like a lee side dry trough or something like that.
And also, pressure trough there too.
Yeah. So that's interesting.
Bruce Linkula weighs in online about the lake effect that the temperatures are right for it also.
Yeah.
We got these low dew points up in the Carolinas up to 20.
Yeah. So we've had one flood of again, we saw it on the satellite. I should have drawn your attention to it. You can see all the stratocumulus coming straight northward today from the Carolina coast, from the straight north toward the south on the Carolina coast, and it's testified to by the really dry polar air dew points you see here.
I think looking at it, I think that's polar air all the way down to Florida, all the way down to Key West.
Yeah, it's 44 dew
Put it
points.
right through.
Yeah.
I can't believe there's a 19-degree dew point. That's
Yeah, look at that. That's 46 for Orlando. That's Magic Kingdom is dry.
That's being brought
All the
around.
bars are closed.
It's being brought around that cyclone that's centered off the coast of the Mid-Atlantic coast.
Yeah.
It's just pulling the whole thing down.
So let's take a look now at our upper level charts. And then we'll go over to Europe just for a minute. So of course the super peak, there's no reason to say it. This is 12Z from this morning. Let's make sure that okay, yeah, it's 12Z this morning. So a broad region of cyclonic flow off the northeast coast of the United States, and the winds are quite strong on the southwest side of this. You've got wind speeds 85 knots at Asheville, 85 also on the coast of North Carolina. So those are sort of the maxima at 500 millibars, 80 in Huntington, West Virginia. So there's a jet even at 500 millibars, it's over 80 knots. So pretty strong, and a broad cyclonic curvature, of course, associated with this trough. And I don't even think it's this feature, of course, that sets the stage perhaps for an environment conducive for this one to develop. Perhaps it's this one, I don't know yet. But this is Friday morning.
So each of those little vortices could be in part responsible for some of the snow shower activity over New York State and over the Michigan this morning.
This one here has a tendency to have its own structure. This one certainly does. There's one here, and so there's several that may be embedded within this broad upper cyclone that are responsible perhaps for that.
There's a weak tropical plume over northern Mexico, and it extends up into Arizona. And some of the lesser, a little bit higher potential vorticity, but still very low, goes all the way up to the Canadian border. And that's why you're seeing all those waviness in the 500 millibar pattern in the west again, because it's not holding its geostrophic balance at the small scales. And so it's breaking into gravity waves that are resonating with the topography underneath. So
You're talking about the small wiggles and the height contours.
Yeah, those are real. Not where they are, because I don't think there's any predictability like that in them, but but they're real because of the low inertial stability of the flow.
Eager to see.
Yeah.
Can
we go back to 500 millibar?
Yep.
So we've got really cold temperatures over this region where we had those showers that were not particularly lake effect. This is pretty cold. I don't know how cold climatologically for, you know, upstate New York. Minus 34 at 500 millibars is pretty cold. It's only 0 at the surface, so the lapse rate's pretty steep, even without the lake providing extra hot spots. It might be enough that if it's moist enough, you've got, you know, free convection.
That's consistent with those sort of cumuliform clouds you saw scattered, not really organized.
Yeah, it almost looks like what you see commonly off the west coast. So maybe that's it. It's just pure stability underneath a really deep upper low. And remember what we saw off the Aleutian chain. This is minus 40 at 500 millibars. That's really cold for this time of year, even this far north. And that was really deep convective clouds. Unusually deep is my guess. Back behind the front, which was also nicely identifiable at 500 millibars. And we saw that big convective patch with the cyclone center being right over the Kenai Peninsula right there. At least the circulation center. So maybe that's it. Maybe it's just really poor stratification and a moist column because there is a lake that's providing, you know, water vapor in the lower part of the troposphere, and you haven't. What would be the lapse rate? So we're only at 5,200 meters here, and it's 32. I thought it was at Albany, so 0, and that's at, let's say, 0 meters. Let's say 200 meters. So 5,000 meters with a temperature drop of, you know, more than 30 degrees, it makes it more, it's moist unstable. So if you've got a saturated or near saturated column, you can get free convection.
There's also a lot of small but very intense vorticity centers going around that low. And I think those small but intense vorticity centers are probably creating local regions of upward motion.
Yeah, that certainly assists. So, you know, you're not going to get something to just erupt because of really weak stability, marginal instability. But if you have an environment that promotes ascent, then the ascent is going to be realized freely.
I think, the large scale is doing
it. That's a good combination. Yeah.
It's a combination of the individual vorticity centers, but I think in the conglomeration of the broad cyclonic circulation, moist boundary area, sort of weak Ekman pumping is helping to force.
That's another mechanism for getting the rise too. Yeah. So all you need is that in this environment, it looks like. So that's interesting. So a lot of interesting things on this map, even though it's a relatively boring day across the U.S. Weather-wise.
But I just for a point of interest, what I have been doing is kind of contrasting this low off the East Coast of what's going to be on what's there like Monday, Tuesday.
Yeah.
Monday, Tuesday is a whole different ballgame. It's much more diffuse and doesn't have a good curvature center. This one is a real solid ball of curvature.
Yeah.
The thing Monday is not.
Yeah.
I'm not sure. I don't know. The one Monday just doesn't impress me as something that's going to have its act together and create a lot of.
There's plenty of reason to believe that. The thing is, it's been weird that it goes back and forth as a substantial threat to one that's no threat at all. And that's a really interesting thing. Michael and I were just looking before he came down. All the precipitation bands, even in the most recent couple of runs, I think, give this an indication of kind of a flat wave. You know, it's all frontogenetical. There's no particular curvature. It's exactly what you're saying. And so you can't get a single center of development. You get precipitation, but
it looks like there's lots there, but it could coagulate. It could aggregate together into something important. But the way it looks right now,
I think what's interesting about that prospect is that the element that invades this environment, and this environment fades a little bit during the time during which this next thing develops, emanates from central and northern Canada, which is resolved to some degree by the observations, but not as well as continental United States. So maybe there's just a little bit of uncertainty in between the observations that keeps on being part of the forecast problem for this next one. We'll see when we get to that point of the discussion. So let's take a look at 300 millibar and see what we get there. I think we're going to see a pretty curved jet, broad zonal flow, which is probably subtropical type jet. We'll see when we go to higher levels. This is definitely a polar type jet with the feature off the Gulf of Alaska, 178 knots in the northwesterly flow. That's the one where we saw the stratocumulus coming out of the eastern Bering Sea at sea level anyway. Very, very cold air aloft. We just saw the minus 40 at 500. It's minus 40 also at 300, so it's isothermal. We've got a really low tropopause over the eastern part of the Gulf of Alaska. And you've got what looks like quite a complicated jet structure here. I think going to higher and higher level will see more complication. The places where I suggested at 500 we had really high winds are also high winds at 300. They seem separate from this maxima. And then somehow they're combined on the eastern part of the upper wave with 134 knot maxima on the southeast side of that upper trough at 300 milliwatts. So let's go to 200. Just skip 250 entirely and see what we see. Yeah, so this does all of the stuff on the southern tier of states has definitely got a subtropical jet component. These wind speeds are higher at 200 than they were at 300, and so you're seeing the underside of it at 300. And this is maybe the core, or maybe not even yet the core of the jet across the southwestern United States into the Gulf of Mexico. And then here we have just about the same jet core speed, a little bit weaker at 200 than it was at 300. So this thing is a deep, maybe unified jet core of some kind. And then we're weaker the higher we go with this one because that's polar in origin. So you can kind of begin to sift these things out and see some structures there. Pretty interesting zonal subtropical jet. And I think a fairly high latitude. That's usually further south. So this is at a pretty high latitude for the subtropical jet. I don't know what the CLIMO is in terms of latitude in that part of the country, but I think that's unusual. So
we've been having a lot of subtropical jet activity going, like I said a couple weeks ago, all the way from Asia, all the way across North America, and way into the Atlantic. This is just a continuous structure of maximums that are moving along in the subtropical flow. It's interesting because it is so far north this time of year, but it's so persistent. Yeah,
it is persistent, and one can imagine there's some upper divergence pumping in the San Francisco Bay region, and of course we have that stream of moisture probably undercutting the jet with the low-level soil releasant circulation driving it forward. It's a nice setup for a river event, atmospheric river event in that location. Pretty interesting. Okay, let's go to Europe now. First, let's go over here, North Atlantic from Canada. Just want to show you this. Here's Iberian Peninsula, and this is the last, 12 or so hours daylight over there. And so you can see there's a pretty intense circulation going on to the northwest of Spain and Portugal. And here's the British Isles. But it's not so easy to understand from a glance how this thing is the Azores. It's not really easy to see how this thing is being put together. Okay, so I'm not going to try to pretend that I've done enough work on this to say anything more about that. I'll just say that Porto in the north coast of Portugal is right near a town called Nazaré, which has right off the coast a really deep trench. Doesn't show up on the globe as significant enough, but locally it's really significant. A deep trench in the underlying topography of the Atlantic basin. And so when it gets windy in these locations, the surf is huge right off the north coast of Portugal. So I want to show you this page right here. So this is called magicseaweed.com. So here's what we're looking at. These are the swell heights in the forecast for the next several days. And you're just getting this storm to develop now. It's going to be at its peak intensity midday to late day on Saturday into Sunday. So we have a 30 to 45 foot swell that's forecast. If we slide down, we get even more resolution on this. And there'll be another thing I want to point out as well. So here's every 3 hours a forecast of the primary swell height and its frequency. And you get all this kind of stuff. I'm not a surfer, but I'm interested in waves. And you get the winds, get an idea of what the winds are looking like and so on. And let's keep going further down. So I'm looking at this column right here for the height. 10, 26, 28 foot swell at 9 p.m. Saturday. Let's keep going. We end up with 50 foot swell at 9 a.m. on Sunday. So a lot of Portuguese will be skipping church on Sunday morning, dragging their 700-pound, and I mean British pound, surfboards down to the coast and enjoying 50 foot swell. On top of that, there's bound to be extra stuff on top of it. So the 80, 90 foot waves perhaps in some cases. And then just zoom in on this for 1 second, Pete. Click on it. These are the wind speeds, and I don't have a scale on it, but Michael and I were looking at it from a Pivotals page, which is far superior to this. And these were in the 56, 58 knot range of sustained winds. And here we are at the north coast of Portugal. This is Saturday night. And so you're going to have massive swell driven toward the coast, and then it's going to interact with this really deep local trench and produce some huge waves. We can go back to the prior page just for a second. I want to just show you an example. There's a photo gallery further north on this side. think it slides up and down. I'm not sure if it does. You know, okay, let's see if we can get a couple of pictures. Maybe right there, we might have passed them. Here are some pictures. This one here is good. This is right at Nazaré. It's unfortunate they don't show you the whole lighthouse that's there, but you can see this is a 6 or so foot person. So this is now 12, 18, 24, maybe 30 feet high. Here's such a person on a surfboard. Look at that mountain of water this person's on. And these people aren't surfing. They just want to see what's going on. This is probably a 90 or 100 foot wave. And you can see that they don't look so big out to sea, but when they get in close, they interact with this really steep topography and produce these massive waves. The very best ones apparently occur with offshore flow. I don't know about waves enough to say why that's the case or local conditions here. There's going to be strong onshore flow this time. So some of the blogs about this are saying otherwise great conditions, really big swell, but it's going to be onshore winds. That's not the best situation. But gigantic waves. Look at this. This is probably a 50, 60, 80 foot transect down this wave, and he's not even close to it breaking. These are enormous. I would love to see that someday. So something like this is about to happen on the weekend. And oh, you don't know. How big is this wave?
Scroll down a little bit.
There's a quiz.
You can answer it.
They're asking how big we think it is.
Let's just say the answer, 50 feet. Oh, I don't know if this is in the same place or not. It looks like it is. So that's a 50-foot wave. Look at how steep it is. Unbelievable. So anyway, quite a place to go. I'd like to go there someday just to see the waves. But you got to go on the right day. Otherwise, it's not that exciting.
Would you want to see it on a board or?
If I had the skill, I would. But no, I don't have the skill. I don't have the skill. Look at that. That's scary. Oh my God. Look at that poor guy. Not sufficient skill. Wow. Unbelievable. So that's all I have. Michael, you can tell us about the forecast.
Thanks, Jack. Today we really got our frequent flyer miles going all the way to Europe. We've look at the waves. We're first just look at the local weather and then talk a little bit about the uncertainties that exist for the East Coast event later this weekend. So here's our meteorogram. John likes that term. You can see the temperature is basically a pretty slowly warming up over the course of the weekend. We're not going to focus too much on the exact temperatures forecast by this. Some dew points beginning to come up. A threat of a little bit of precipitation this weekend. We'll sort of check out what's perhaps the cause for that. But I would say otherwise a pretty boring weekend. So that's why our focus will be more on other parts of the globe coming up. Let's go back a quick. Look at our time height section, and it's going to be boring. This is probably the definition of a boring time height section. Maybe not so much for the last part of this, but see generally a flat tropopause, dynamic tropopause over us, no big undulations in it. Correspondingly, we can see the isotropes, the yellow contours here on this map, indicate not much in the way of change in the lower troposphere, at least in terms of the temperature structure. And we can see just the, what we kind of expect every day during the course of the diurnal cycle, mixing out, creating a sort of well-mixed layer getting created today, tomorrow, not so much on Sunday, with a freshening northeast wind and slightly cooler temperatures at the surface. And maybe the threat with increased relative humidity over us, perhaps that's indicating chances of some cloudiness. So it looks like tomorrow will be a nice day. Sunday, not so much in terms of maybe could be a little bit of damp, but also with a few clouds, but nothing significant, at least from this viewpoint, this looking at this particular setup of this cross section. And wind direction generally westerly, southerly during the day tomorrow, and then becoming easterly as we get perhaps a backdoor front coming through. You see the isotropes kind of outcropping during the course of late tomorrow evening through Sunday. All right, let's go back and quick. Let's look at, these are a series of maps that I really haven't had time to look at this morning, but we'll look at the lower tropospheric potential vorticity with time. And we can see a couple of features in this northwesterly flow. We look at the potential vorticity as in the animation. Here's one feature that comes through in this northwesterly flow that's approaching the East Coast near the end of the period, and that's perhaps going to be one of the triggers for our weather events along the East Coast. But for us, over the course of the weekend, not much happening. There's this brief period. You can stop this, or not, can't stop the loop, but we can go back and click, and just go to, let's say, 24 hours at this level. Okay, we're in this broad northwesterly flow aloft. Here's his upper trough that's coming by minus 460 maxima. Let's go 12 hours ahead from this. Hold this right here, ahead 12 hours. Is progression eastward. So now we're looking at tomorrow evening. So this is approaching. Go ahead another 12 hours for Sunday morning. Move southeastward or east southeastward. And so we're looking at higher values of potential vorticity. This is light, the darker greens, the lighter greens. So this is, you see the wind shift associated with it. This is pretty, it's not a strong upper trough, but it's weak when we saw no big triple fault undulation when this feature goes by around the time that we're expecting the column to moisten up a little bit over the weekend. A nice broad ridge out to the west. It'll be nice to be under this at some point later in the forecast. And let's go back one more click, and we'll go to last time in this sequence. Okay, so that trough slowly beginning to migrate by us. But a really broad, expansive anticyclone, big trough in the potential vorticity, or a big ridge in the geopotential height. It's going to be out of the western part. That's a nice little narrow bit of vorticity over the center of this big broad ridge. Let's go to 500 millibars and look at the same sort of depiction. Start at 24 hours. Again, here's that upper trough. Kind of more impressive maybe in this sequence of maps. Go ahead 12 hours and just watch its southeastward progression. Again, just the same view. Vortex over Nebraska. And the curvature is not significant for this.
Yeah, it looks like it's headed into a meat grinder too on the coast, doesn't it?
Right.
That confluence zone.
Here's this broad region of confluence, so this initially balled up trough is just getting kind of stretched out in this very broadly confluent flow. If this is the feature that's responsible for a sort of east coast of that, it's really going to get, the deformation that's acting on it is not favorable for it to really fall up. Let's go ahead another 12 hours. We have it sort of stretched out like this. Right, blocking that.
I think it's the same one.
That's the same idea. It's continually getting stretched out, broadly confluent flow. That's not really going to be favorable. Advections downstream of this aren't going to be really favorable for significant precipitation. There is a nice curvature maximum. You're going from cyclonically curved or anticyclonically curved, so that sort of the region of divergence that would be downstream of this that would be favorable for ascent if it's moist enough. And I imagine as this is approaching the upslope flow that's going to be preceding it, that might make it favorable for some heavy snows in the mountains in Virginia and West Virginia. But that's probably about it. Let's go ahead. Let's go back and click and go to 60 hours at the end of it. Let's look at the surface. We can step forward. We'll start at 24 hours. This is accumulated 6-hour precipitation. Again, lots of showery precipitation. This is again tomorrow morning. Certainly cold enough in the east for snowfall for us. Again, this big broad anticyclone. Not much to talk about there. Weak temperature convection over us at 36 hours. Precipitation out to our west in this region of warm advection on the western side of this anticyclone. And not much on the east just yet. Let's go back. 48 hours. This one that precip is expected to arrive here on Sunday with the upper trough. But again, still not much for us, and certainly not much out in the east. And then finally, 60 hours. Yeah, it's just a one pretty exciting at all. Here you can see, again, some regions of precipitation have occurred around this upper trough, still out to the west. So you see precipitation in the eastern part of the United States, but this is not very well organized at this particular time. So, and for us for the weekend, it looks like any of the precipitation is going to be well more south and west. The GFS forecast for the same time we'll look at it in just a moment also doesn't really indicate much for us over the next week or so in terms of precipitation. This feature is expected to slide well more south and east. But what about this east coast of that? So let's go to the pivotal site, please.
Well, that looks like a broad barochromatic zone draped across the Carolinas to the west of Missouri, but no particularly robust upper trough. That seems like a missing ingredient.
So that's what you're going to want to get cyclone. So what I'd like to do is let's just step.
Michael, before you go on too much, are you planning to do the West Coast too?
No. If you'd like to, certainly.
The Gulf of Alaska has an unbelievable, historic vorticity maximum in the Gulf of Mexico, Gulf of Alaska by tomorrow afternoon.
Okay, we'll take a look at that. We'll take a look at that.
Take a look at that.
But I just want to just focus on, if we can step ahead, this first 6 hours, we'll really go through this quickly. And let's go to precept and typing rate. Okay. Again, here's a light snowfall that's expected over the, we saw in the Great Lakes today and over New York State. Really dry, cool here, not particularly exciting, and very weak temperature reduction. Let's just click ahead. We'll go to 24 hours. I really want to get through this. There's some light precipitation in the southern Appalachians, or the central Appalachians. And again, not much over us. This is tomorrow. We'll go ahead 12 hours to 36 hours. Precip was off. Here's this light snow that's just to our south. You can see the nice inverted trough over us ahead of this upper trough that we saw in the 500 millibars. 48 hours. And there's the snow. We're missing some snow just to our south. Yeah, this is not particularly exciting, but it's really moist and a lot of precipitation. And the southeast, so ingredients are coming together, but what's going to happen in terms of actually the weather? So we'll go ahead now. This goes 60 hours. This looks far more impressive, all right, with the precipitation. So that's moderate snow in the mountains of Virginia, Charlottesville, Roanoke area, and maybe Richmond. It's on the rain snow line. A nice variability. We go up to 500 millibars. I just prefer feet sample 500 millibars for these, but you can certainly get a sense that there's a thickness trough as well in the west here. But again, not very organized in terms of the sea level pressure at the surface. Let's go up to 72 hours. And then this just falls apart. Now here's what's I think is just really confusing. Let's imagine we wanted to start off looking at this forecast for this particular time. This is valid Monday morning, back on Tuesday of last week at 18. Here's what the models were forecasting at that time. Again, cyclone, precipitation extended well to the west. This is certainly a light snow event for the big cities, Baltimore, Washington area, extending all the way back into West Virginia and Virginia, Northern Virginia. Now let's just sort of step through this. Maybe we'll go for every single one. Really intense storm. This looks really good, right? But it's just south of the area. But Richmond's all snow and Allbush, Roanoke, these areas. Really intense cyclone, sub 990, 988 at this point. Let's go back. Let's go ahead. Yeah. This really looks good. Wind and snow over the Delaware Peninsula, southern New Jersey. Good. You can say generally the same story that nothing. I mean, that's really zero pressure data. And that's a little different structure, but still a fairly intense cyclone with the rain snow line a little bit further west toward the big cities. And you still have this, the headline would be big storm possible for the East Coast, or almost likely perhaps when you see the persistence of this in the forecast from 18th Tuesday forward. It is all valid at the same time. These are different model predictions, different data that's gone into the model, same equation set. Let's go ahead. Good. For decent, moderate snow event or storm along the East Coast. Yeah, it's Thursday. Strung out a little bit, again, nice cyclone, but no obvious upper trough. One of the other big features for a significant East Coast storm, don't always need to have it, but it's generally helpful, is a big anticyclone over eastern Canada, which doesn't exist there.
10 millibars weaker too at the central pressure.
Right. So this is now, this is now a much weaker cyclone. Let's go a little bit closer. So again, you think, snow, this still looks like a decent snow event, okay? We're closing in on the more recent times. That looks pretty solid.
It's really good.
That looks really good. And then we get back to, so first of all, I mean, the one thing that you might say is that given that the last several sequences of forecast were forecasting snow, and this is the first one that really doesn't have that for 12Z on Monday morning. Maybe there's something weird about this forecast. This sequence of maps is actually more supportive of a snow event,
I know, I agree with that.
Than what we saw this morning. But I think the timing of this, we focused on one particular time. This is a little bit bizarre. So, one of the interesting questions, if we had time to look at this, and students interested in looking at issues related to predictability and forecast uncertainty, is just taking this forecast, and again, a quick back one, please be.
one that just preceded it, the 16 one. What's the difference in the evolution that gets us to this stage versus the other one? This is really an interesting question. If you can understand that, that would give you some insight as to why this next sequence is a little bit weaker. We could also look at just different forecast models. If you go over here, look at the NAM from the reasonable time interval, we'll look at that. And that has the whole system much further to the south. And if we also look back at some prior NAM forecasts, we don't have many of them, unfortunately, since it only goes out to a certain point. And this has the cyclone over south, but well to the south and east of those cities in the Mid-Atlantic. That's suggesting nothing. For the GDPFS, this is the Canadian model at the same time. $8. And that's offshore. And we'll look back, we don't have to look all of them, let's go back to Wednesday or Jersey Wednesday. That was even slower at times.
Wow, yeah, totally different. That was way up.
So, it looks like this morning's BFS.
Yeah, it does.
Kind of like this morning. So much more strung out weather system. Again, we have this trough that has this northwest to southeast tilt. It's the curvature in it. Let's actually go to 100 millibars, not the thickness. So then it's right here, the vorticity and height. And you're not going to get, it's not obvious you're going to get any big storm from something like this flat. And if you look at the GFS for this might be useful. We go to GFS. So let's actually go to the current GFS. It's very similar. Strung out vorticity, a little vorticity maxima embedded within this, but this is more of a shear line than a really nice, well-curved upper trough. If we were to go back just 6 hours from the initialization, what's the difference between these two? This little bit in here, I don't know if that's.
Yeah, it's a little bit more curved.
A little bit more curved, but still, it's the orientation of it's also not.
Yeah.
So the most favorite. So this is, if we were to go back just the times when we had a much more robust cycle, let's say 0 on Thursday, that's different.
Yeah, that's different.
Look at that. And so you really have a nice purple just the next. Again, there's no time. I didn't have time this morning or over the course of this week to really follow this, but this feature right here, looking back at its origins and its evolution over time, is probably maybe the key to understanding why this event may or may not occur. And we can probably look back next Friday. Probably have saved some of these images next Friday to see what actually happened. Did we get something that was note in the Mid-Atlantic, or something that was in here? Well, Greg had mentioned that there are some interesting goings on over the Pacific. Well, in this view, and
That's a wavy flow.
Get up by the Gulf of Alaska.
okay, so let's go to the initial time first, so we have to. Okay. We have Gulf of Alaska, and the feature is going to be, you said tomorrow?
Yeah, tomorrow, Saturday night. It gets really strong. The vortex is
Oh, you should have a current one, that's a good thing. Not available yet?
I think we're at the wrong time. That should be 0, so you're close to the
Okay, good, so then, that's it.
doesn't look that impressive on it.
No.
Where were you looking, Greg?
Well, I was looking at my inertial frequency plot, and I saw a huge area of very extreme curvature. Maybe vorticity versus curvature. If you just look at the curvature stuff, it's it's really interesting. Look at my plot. And look at the 348 down there again. 6 run. You see that big ball out there?
Yeah.
Let's go back to like the Saturday morning part. And then that comes into the West Coast, which is interesting. Look how big that is. Holy mackerel. Look at all over the globe. You hardly see anything anywhere else that big. And that's just curvature over that whole area. I don't know. I don't know exactly how to interpret that, but it's pretty impressive. Now, when it comes into the West Coast there by Monday, that's pretty impressive in the sense that it's got a little bit of a tropical plume ahead of it, and then there's going to be a big moisture plume coming in there too.
And you talked also about this and use the term spokification. What should we be expecting?
Well, that's what we're seeing on the map now, all that waviness and
Right.
500 millibar gravity.
This is tomorrow morning.
But even now, what that does is it lowers the inertial frequency, and so now at the finer scales first, they lose their geostrophic balance. So the wind coming through in balance kind of wrinkles up over there and becomes wavy at a fine scale, which are gravity waves.
Right. But when we go to early next week, when this is crashed onto the west coast of the United States,
Yeah.
Monday, goes to
No, that's-
Tuesday, even further.
I see this big plume coming into the central.
Yeah, keep going. I know what you're talking about, Michael. When it comes down across the.
Right.
Yeah, look at that.
Right here.
Now,
So-
that looks like a severe
Severe
weather.
weather, okay, so that was.
Yeah, because you've got the Mexican plateau going out at 700 millibars and higher,
Yeah.
and then you've got some really strong forcing for ascent in the same location. That's going to be pretty interesting.
So Oklahoma
pattern
there
state.
is really, we're gonna see some interesting
So
weather.
if we get the boom site at the same time. Same run too, so a 60 run. 150 hours.
Yeah, it's not far enough yet.
Also, that's kind of interesting, this kind of really messy.
Yeah, well, that's that stuff that we were seeing. That's the
Okay, all right,
spokification.
and then let's look at the surface.
Well, it's not
We need to
the
go-
right time yet.
Yeah,
It's only
okay.
Thursday. Even further than this, we wanted to go to
It
Saturday.
was Saturday, right, okay, so I get, I was going backwards, okay.
Keep going. We want 12Z or 6Z on Saturday. Right there is about the same time.
Yeah, well, to get this look, this structure, and it's beginning to offer an explanation for why we often see this looks kind of bizarre. Let's look at let's look at the surface map first.
Is there any moisture?
Yeah, like.
There's just been so much dry Canadian air. Boy, okay.
Out to the east of this.
Uh-oh. Boy.
Can you do 2 meter equal? Can you click on that?
Whoa. Stops in a latitude circle somewhere in central Iowa.
Look at this.
That's kind of weird.
This is called the Minnesota moisture.
Anvil moisture.
What's the anvil?
Yeah.
Watch out. So I imagine if that area, very low inertial frequency were to then move over this region where there's significant moisture.
Yeah,
So you see what the low inertial, one of the things the low inertial frequency does when you have individual convective clouds and they have to push their outflow. And the inertial frequency is high, you can get geostrophic balance. And so you can only get 1 or 2 because they can't get a lot of divergence. But if you get that low inertial frequency, you get zillions of supercells. They can all push their outflow without much resistance. So it allows many more cells to occur when you get the low inertial frequency.
Okay. So let's look at the precip at this time and then even go a few clicks forward just to see the dimension. I guess maybe we can go back to the more national view. Okay. All right. But as this trough moves eastward into the plains, maybe it's just into early the following week. Like cyclone in the central part of the United States.
Yeah, probably a lee trough dry line out there. Oh, there it is. Maybe.
It's like convective and maybe very well convective. You could probably look at some other indices for that. A nice well-developed storm activity.
Yeah. Looks like Stormfest, except we didn't know about these broad features aloft at the time, the way I think we do now. It looks kind of similar. I bet there's some structures that are similar.
Snow and stuff.
Yeah. And just to round it out with current forecast adding someone.
Oh, it's more progressive.
All right, so they're showing these things kind of later, aren't they? I think we were looking at early next week, whereas these are just over the weekend. Right?
This is the
Yeah, next
following weekend. This is the
next
following weekend.
Oh, this is a different,
Right.
okay.
But it's part of that trough that's moved it, what's the saying here? So, a couple of things, we just go a week ahead from this morning. If you look at the total accumulated, this looks really nice. This actually verifies this weekend will be just much nicer than this weekend. But the other thing is the amount of the forecasted total accumulated precipitation for this model run. We could also play the same game of going back and forth. This is this weekend's precip that moves to the south. Same thing for the east coast, and then it's sort of a hole there, but most of it stays out, still stays in southern Virginia. If you look back at model run, I think you can see much difference in this.
Yeah, we're in the bald spot.
Yeah, here's where the difference is, but we're still in this relatively broad, for the next week or so. So generally, I think if this holds, we should be pretty decent over the next week. Not much in the way of precipitation, but not a big warm up as well until we get to later next week. So
All right.
Yeah, unless there's something else people will look at.
GFS plumes for.
GFS plumes?
For dollars.
Wait a minute, look at Southern California then.
That's with that initial, yeah.
Look at, I mean, Southern California, those 2 yellow dots. You gotta worry about that.
In terms of flooding,
Yeah.
oh, okay, flooding, but,
Anywhere else, it wouldn't be a big deal, but yellow is what? How much is yellow?
yeah, we can,
4 point something?
4 point something?
Yeah.
Yeah, if that's on the coastal range, they're in trouble.
Yeah.
we'll see that coming up. So two things, a request for the GFS plumes. I think we just actually put in plumes here. If we look at single deterministic runs, it'd be nice to see a GFS. Maybe, yeah, GFS plumes. This one.
So it should default to dollars.
Okay.
We're interested in the snow forecast. Oh yeah, I guess they moved the site.
Right, this is for Dulles.
If you, yeah, you can
Yeah,
drop
we
down
got-
snow.
We can, yeah, change this to snow. So,
I was looking at the 0 zeros, to go back a cycle, in terms of where the GFS basically fell within the spread of solutions, and so the blue line is the GFS.
okay,
So, it's basically on the upper envelope of the ensemble numbers, or the ensemble meetings, or packages. Right.
that's interesting. I don't know if they do the 12Z up yet. Is that available?
Yeah, I don't think so.
So going from the 0 to the 6, I think it came down just a little bit.
Yeah. But it's still on the high end of the collection.
Right.
And I don't think it's really changed its relative position very much.
And the difference between these are, this is at a slightly higher resolution than the other model,
Right.
the other ensemble.
And it looks like there's some different evolutions within that. Right there. Some clustering going on.
Some of them are in the layer with the snowfall.
Oh, yeah, with onset times and stuff?
Yeah.
Yeah. That's,
Right. We can look at a greater granularity. Either click on this, zoom in a little bit. Move over. Hopefully, probably just can go through. Let's go a little further to the south. Still a pretty decent amount. 8 inches. This is the Tucson Naval Air Station at HK.
yeah, that one looks like the ensemble's mean splits the difference between two groups. Wasn't really what it looked like at DCA.
Yeah. Some of these are even later start, but this is later, a different, totally different event.
What an interesting
The
site.
NMS is showing the peak snowfall in like around Charlottesville.
Okay, so if you're right here. Oh, no, yeah, right here. Yeah, that's wrong. That's right. Yeah, huge,
Yeah, that's more like Dulles, isn't it? Yeah.
Okay.
Since we're here and we're, we live in Madison, but maybe to finish off. We'll go back for Madison. Oh, we have to go back to, let's snow.
Let's snow. We don't get any,
Yeah,
yeah.
I thought it was a 12 for a second, I'm like, what? No way, okay. That's the QPF. Right. And there's our temperature forecast. So that blue again is the GFS temperature. So this is about a week out. It's our first 60-degree day.
Oh, it's possible, yeah.
You can see this delayed warming. Not quite.
No, that gets rounded up.
That's pretty
Officially gets rounded up
Yeah,
to 60. CTAC's all-time high is 99.9, and it's rounded up to 100.
Now, this is
I know.
Milwaukee, right? No, it is
That's
Madison.
Madison, yeah. Thanks for that suggestion, Ryan. For the,
Yeah, that's great.
To look a bit more. In our forecast. All right, well, thank you all for participation. Thanks, John. Thanks.
Thank you, Michael. Thank you.
Thanks, Greg, for continually showing us those.
Yeah, Greg, that might be the most impactful effect of that blob of large curvature in the big upper trough, the thing in Southern California.
Yeah, it's in Southern California. Yeah, could be.
All the times we see those,